Hi guys! Today we're starting Chapter 6. Chapter 6 is about solving systems using many different methods. Today specifically, we will be using graphing. Graph paper is mandatory for the next 3 days. So if you need to, pause the video and print out some graph paper, you should do that now. Graph paper will be mandatory for our notes as well as homework. So bare minimum, you need 6 pieces of graph paper for the next 3 days of school. Before we get into graphing though, let's talk about what a system is, because that's what this whole chapter is all about. And so it's important that we understand what a system is and what our goal is on these problems. So what is a system? A system is a single problem with 2 equations that have 2 variables in them. So if we're thinking back to our linear equation chapter that we just completed, each problem had an x and a y. And now, instead of just one equation, we'll have 2 equations. When we're solving a system, we're looking for a single ordered pair that works in both equations. Now, when I say works, I mean it is a solution to both of the equations. That means if you plug the ordered pair into the equations, it gives you a true statement. Now, we want a single ordered pair that works in both of them. So while you might be able to find many ordered pairs that work in only one, you need that one ordered pair that works in both. Today, and for the next 2 days after today, we're going to focus on how to solve a system by graphing it. So again, grab that graph paper. Here is our first example. You'll notice that I put 2 equations, x plus y equals 1 and x minus y equals -3. And what we're going to do is we're going to graph both of these equations on the same coordinate plane. So since there's 2 equations, we'll get 2 lines. Essentially, we're looking for a point where those 2 lines are intersecting, where they cross. Now, not necessarily that they're perpendicular and they're crossing at a 90-degree angle. Don't really care about that. What I do care about is just that they touch at some point in time. And I'm looking for that ordered pair where they're touching. Since we're looking for an exact point where they're touching, in these problems, it'll be best to graph them in slope-intercept form, and it'll be best to graph them from edge to edge. So going all the way across the graph, and not just doing like 2 points or 3 points, like as many points as possible, because we don't really know where they're going to intersect. And if they're intersecting somewhere up here, we want to make sure that our line was drawn as accurately as possible. Even using a ruler, you can't be guaranteed an accurate line. The best way to draw the straightest line possible is to do your slope as many times as possible. Now, just a refresher, these are both in standard form, and to change something from standard form to slope-intercept form, it's at most 2 steps. Step 1, subtract your x to the other side. Step 2, divide by the number in front of the y. Now, you should pause the video right now and try to change both of these to slope-intercept form. For the first equation, to change it to slope-intercept form, I'm just going to subtract the x to the other side. There was no number in front of the y, so I don't need to do the second step. Now, again, graph paper is mandatory because not only do you want to draw your slope to make it as accurate as possible, but also if you need to draw on graph paper to make it accurate. You're not going to be very accurate if you're drawing on lined paper. So on your piece of graph paper, draw your coordinate plane, and let's get started graphing. To graph this, I'm going to start at the +1 on the y-axis. And my slope for this problem is -1 over +1. So that means I'm going to go down 1 and to the right 1. Now, again, I don't want to do that just once. I want to do it as many times as I possibly can. I'm going to keep going, keep going, keep going. I'm going to go in the opposite direction as well. So remember that every slope can be written in 2 ways. So I could also go up and to the left. So notice how many dots I have. Now, I already knew where this was going to intersect, so I didn't go all the way across the board. But when I'm doing my homework, I do usually do dots all the way across edge to edge. And then we're going to connect them to make a nice straight line. To change my other equation into slope-intercept form, I subtracted my x, and then I divided everything by the negative sign in front of the y. And so my new equation is y equals x plus 3. For this equation, I'm going to start at the positive 3 on the y-axis. And my slope for this equation is positive 1 over positive 1. Now, the goal of this problem is to get the lines to cross to intersect. So when I do my slope of up 1, right 1, my line is getting further away from the first line. So I'm probably not going to keep going up and right because my goal is to touch the line that's already drawn. So this is where it's important that you remember that every slope can be written in two different ways. So the other way I can write this slope is -1 over -1. And so going back to my original dot, I'm going to go down and left. And I've just put a dot on top of another dot. That's when you can stop. When you're graphing your second line and you put a dot on top of another dot, you've done it. You've found your solution. Now, I do still want to see that you drew two lines, so make sure that you have your two intersecting lines on your graph. But the graph is not the final answer. The graph is actually the work that you're showing to get your final answer. And your final answer should be an ordered pair. Just as a refresher, ordered pairs are in alphabetical order, x comma y, and they go left and right first and up and down second, kind of the opposite of slope. So we want the ordered pair for this dot right here. So I'm going to go left 1 and up 2. And so my final answer for this problem is the ordered pair -1, comma 2. Okay, so ordered pair answers, the graph is the work, the answer is an ordered pair. Since we're already graphing two lines on each coordinate plane, for your homework tonight, you will need a separate coordinate plane for each problem, since every coordinate plane will already have two lines on it. So make sure that you're doing each problem individually so that you can also really tell where that ordered pair is. And then don't forget to write the ordered pair for your final answer. I'm going to put up two more problems, and if you want to challenge yourself, go ahead and pause the video and try graphing these on your own. And then when you're ready, come back and check them with me. For the first graph, I started at +1 on the y-axis, and I went, the slope is +3 over 1, so up 3 and right 1. Or I can do the complete opposite of that and go down 3 and left 1. And so there's my first line. And again, look, I drew a straight line, but it doesn't even look like it's going through the dots. So that's why it's really important that you are graphing the dots, because the dots will be more accurate than your line could ever be. For my second equation, I started at the +2 on the y-axis. And my slope for this equation is 2 over 1, so up 2 and right 1. And right there, I just put a dot on top of another dot. That's why you can't really tell that it's there. It's right here. So I am still going to draw my second line so that I can very clearly see that I have two intersecting lines. They're not perpendicular. That doesn't matter. I don't care about it being perpendicular today. Today, I only care about where do they cross? Where do they touch? Where do they intersect? And these two lines intersect at the ordered pair 1, 4. Now, again, it's important on your homework tonight that you do not graph two problems on the same coordinate plane. So I'm going to go ahead and erase this coordinate plane so that I can graph my second problem. For my second problem, the first equation's in slope-intercept form. If it helps, you can write +0 afterwards to help you figure out like where to start. And so in this problem, we'll start on the origin. And my slope for this problem is 5 over 1. So up 5, right 1, or down 5, left 1. For the second equation, I do need to change it to slope-intercept form. It is not currently in slope-intercept form. So I'm going to divide both sides by 4, and I get y equals 1 over 4x. And again, if it helps, you can write plus 0. Now, as soon as I graph my y-intercept, I do have my 2 dots on top of each other, but I need to show that they're intersecting lines. So I do need to go ahead and continue with my slope. So up 1 and right 4, or down and left, so that I can very clearly see that I have 2 intersecting lines. If you're just drawing one line, it doesn't look like you found the answer. And if you're just drawing dots also, it's not dots. These are linear equations. They do create a nice solid line, not just pieces and points on a graph. So make sure you're connecting your dots and making a line. And these 2 lines cross on the origin, 0, 0. So again, just a couple pointers for tonight's homework. You have to have graph paper. It's mandatory. You want everything to be in slope-intercept form, and you want to use your slope as many times as possible. Your final answer will be an ordered pair, but I'm still going to be checking to make sure that your graphs each have 2 lines that touch. And that's the end of today's video.